Hello, so my name is Gordon, and this is the question we are about to do. You can read it over here. And then, so it's 2 blocks of rest joined by a rope. So we have a pulley, hanging, and then we have a cannon, and then it hits, and then it makes a collision. So, and then we have to determine the distance block being traveled in total. Okay, so what this is, let me just draw the diagram so we can better understand the question. So you got the cannon, 40 above the horizontal. Yep, above the horizontal, 30 degrees above. And then shoots our marble. And then it hits this block. Block A. And then it goes down here. Block B. And then once it hits here, it collides. Right? And we have to find the distance that the marble traveled. Because after the collision, the marble will bounce back over here, and then this will move, and B will move as well. So let's just do the marble part first, right? So it's just a typical projectile motion question. So 30 degrees, 20 meters per second, and then that's V initial. And then we have to find the x component, which is Vix equals to 20 cos 30, and we all in perfect triangles, right? 30, and that's 30, and then that's 2, 1. So that just equals, so cosine 20 equals to root 3 over 2. The 2's over here cancels out, so that's just 10 root 3. Now, since there's nothing, it doesn't say anything that's changing the horizontal component, thereby Vix equals to Vfx. So this is the final velocity, right? Because there's nothing that's changing the horizontal velocity. Now, in order to find the distance, we have to run range equals to dx, right? Which equals to Vix delta t. We have Vix, right? But we have to find what's delta t. So we could use one of the big fives over here, right? Big five equations in which the acceleration is just gravity, because it's just the force pulling it down. And dy 0, because once the marble hits a table, the vertical distance it traveled it stays the same, right? 0, 0. And then we can start expanding out this and factor out delta t, so you can find for delta t. So Vi sine theta minus by 1 over 2 g delta t, and this is at initial, right? Time at takeoff, and this is the delta t we want. Well, this is the one we want to find. Sine theta over by g. We can plug this thing inside here, which then equals to let me see, Vi cos, and then 2 Vi sine theta over by g. And then we can use the trig identity, which is, right, 2 cos sine equals to sine 2x, or sine 2 theta. And once you plug in the values, it's just equal to, right, equals to this. So g sine 2 theta, and then we just plug in, so that's 20 meters per second, square root that, divide by 9.8 meters per second squared, and then sine 2 times 30. We pull out the calculator, right, and then we try to calculate that, so that's 400, 9.8, 40.8 for 1, and then time, that's sine 60. And then what you'll get is equal to 34.348 meters forward, right? Because that's the horizontal component. Now, that's the distance the marble traveled just from the cannon itself. Now I have to find the collision part as well. right? So once it hits over here, right, M1 equals to 0.1 kg because 100 grams is just 0.1 kilograms. V1 equals to, right, 10 Vx, yeah, 10 squared free. And then M2 equals to 5 meters per second. V2 is 0 because it's at rest. Now, you want to use, right, the collision formula, which is this, FF M2 F2. And using the formula for elastic collisions, right, which you can use by substituting this formula, right, and as well as the fact that the energy is conserved the same, which is this, mv1 squared plus by half of m2 v12 equals to 1/2 m1 vf1 squared plus by 1/2 m2 vf squared. You'll get the equation to find for vf1, which equals to m1 minus by m2, m1 plus m2, and then that is equal to vi1 plus by 2m2 over by m1 plus m2, and that is vi2 over here. Vi2 is 0, so this thing just equal to 0 itself, and now it's just this important part. Plug in the values, 0.5 minus by 5 over by 0.1 plus by 5, and then 10 square root 3 meters per second forward. We will eventually get the value, which is negative 16.641 meters per second forward, which this just equals to 16.641 meters per second backwards. Now, to find the distance for the marble, right, it's just the distance from the cannon itself, and then plus by the distance from the marble after the collision, and moves for 2.2 seconds. So that's just equal to 35.348 meters forward, mass by 16.641 meters per forward, and then times by 2.0 seconds. This will eventually equal to 0.66 meters forward, which then rounds up to 2.1 meters forward. Thereby, the marble traveled 2.1 meters forward, right? And we use negative because for forwards it's negative 16.64. So we just plug that in and we get that. So that's how much the marble traveled. Now we have to find the other part, which is block B, how much it traveled. So let's just get a diagram here. Right? Okay. Get that. That's A. That's B. And then we have this part, which is FA plus FA. And then we also have another force. Let's just around over here as well. It's FT. And another force that's pushing this up, which is FT over by FG. And we have FK. And F and FG like the usual. And those parts are equal. FTs for both of them are also equal as well. So for the top part, right, oh yeah, let's just let this be positive and top be positive. So M1, right? So the net force of the top component is just FA mass by FF, well, FK you can say as well, plus the tension force. We can substitute out, and isolate for, well, not substitute, I mean isolate, my bad. Equals to FT, and this should be minus. There we go. And we're isolating this because the tension force between the top and bottom is the same. So for the bottom, after you isolate, it's M2G minus by m2ay. Now the reason why you want to have a minus sign is to match up with the top part, right? If the top part is positive, then the system on top of here is moving up over to right, and this will lead to the system at the bottom moving downwards because ft will become smaller. Okay, so we have m1ax minus by fa plus fk equals to m2g minus by m2ax. And then this is when we just plug in, well, we just write the values inside. So 5ax, right? Mass of the first mass, which is this one, m1, and this is m2. Ax plus by the friction force, which is 9.8, right? Because it's k equals to fn and then mu k, right? So that's just mg. And then times the mu k, which is given as 0.8. And then minus by the 50 newtons, because that is the applied force. It hits with a force of that. So 50 newtons is applied. Equals to by mass second one, which is 9.8 minus by 4ay. Once you subtract all this part, as well as move this one to the right side, you get that 5ax minus by 59.5 equals to 4ay. Now, because this is a pulley system, the acceleration of on top over here is equal to this one. The magnitude is the same, right? So we can move that around and we'll get that 9a equals to 59.5 meters per second. Well, this is in newtons. But yeah. And then we isolate that. A equals to 59.5 divided by 9, which then is approximately equal to 60.1 meters per second squared. And then in this situation for this part, it's heading down. If it's up top, then it'll be right heading towards over there, heading towards the right side. Now, once we have the acceleration, we just plug it inside one of the big four formulas. Delta D equals to VI1 delta T minus by 1. Since the system was initially at rest, this just equals to 0. Delta D equals to, plus that, 6.611 meters per second squared down, 2.7 seconds squared, which equals to 24.097 meters down, and we have to round to 2 sig figs, so that's just 24 meters down. Thereby, block B traveled 24 meters down, and this is it. And yeah, my name is Gordon, and this is the question and the answer. So 2.7, and as well as this one.